Today, I will continue the fundamental hydrodynamics, but just to remind you for something. Last meeting, we decided if we have a pipeline and we have flow of water, we decided based on the continuity equation, if you have section number 1, probably in a city like Commerce, and we have section number 2 in another city like Greenville, the same pipeline, so I can say area V at section number 1, area V at section number 2 must be equal. And both of them equal the discharge Q, which called flow rate. That makes sense? So based on the continuity equation, AV at any cross section of the pipeline will be constant. Area V equal area V. Guys, just a second, I will be back. Sorry, guys. So area V, area cross-section area time velocity will be constant. We covered this last week. Today, I would like to share something with you. At this location, we have velocity because we have flow. We have pressure. I believe if you have a hole in this pipe, you can expect water flashing like this. That makes sense? So this water is under pressure. So at this location, we have pressure. And also, if you assume the center line of this pipe has a distance Z1 related to a reference line, so I can say at this location, we have this term. P1 divide gamma plus Z1 plus V1 square divide 2G. P1 divide gamma plus Z1 plus V1 square divide 2G. At this location. At the other side, we have the same parameters. V2, velocity, I'm not sure will be the same or different. P2, pressure, I'm not sure will be the same pressure or not. And we have Z. To make sure that Z1 and Z2 are measured from the same reference. We have a reference like this. So what is the height of this center line related to this reference, which called Z2? What is the height of this center line related to this reference called Z1? On the other side, we can say we have pressure P2 divide gamma. We have Z2. And we have velocity 2 square divide 2G. Both of them must equal. This equation will be called energy equation. Or sometimes we can call it Bernoulli equation. So P1 divide gamma plus Z1 plus V1 squared divide 2G at one cross section will equal P2 divide gamma plus Z2 plus V2 square divide 2G at another section. So we are talking about different parameters in this equation called energy equation. P1 and P2 pressures at section 1 and section 2. V1 and V2 velocities at section 1 and section 2. Z1 and Z2 are vertical distance from a reference, from a datum at section 1 and section 2. To set up a relationship between these parameters at these two sections, I can say this energy equation. Just for your information, this term, which called P1 divide gamma, and we understand what is the meaning of gamma. I believe you understand this. Gamma is the unit weight of water, which is 9,810 Newton per cubic meter, or 62.4 pound per cubic feet. So this term, P1 divide gamma, can be called pressure head. Z1 can be called elevation head. V1 square divide 2G can be called velocity head. Guys, make sure you understand this point. V1 can be called velocity, but V1 square divide 2G, the whole term is called velocity head. We have pressure head plus elevation head plus velocity head at section number 1 must equal pressure head plus elevation head plus velocity head at section number 2. So this slide is very important. Please pay attention because it's very important part in your FEE exam to understand this equation, which is called energy equation. Energy equation is a relationship between different parameters: velocity, elevation, and pressure. Make sure you understand these terms. The first term, which called P1 divide gamma, can be called pressure head. The second term, which called Z, which called elevation head. The third term, which is V1 squared divide 2G, can be called velocity head. Any questions so far? Any questions so far? If you have any question, let me know. Guys, this energy equation can be applied to any system of flow. For example, we have this tank and we have this pipe. This pipe is connected to the tank at the bottom. So we expect flowing from this tank to outside through this pipe. That makes sense? That makes sense? So we need to determine the velocity of water at the outflow end of the pipe. What is the velocity here? I expect the flow will get out from this pipe with a velocity. What is the velocity here? If the elevation of the center of the pipe at the outflow is this elevation at 525 feet. and the surface of the reservoir of this tank, this surface at elevation 550 feet. What is the velocity at the output? Okay, guys, we can use the energy equation. But first of all, you need to determine what is the two locations you are looking to apply energy equation. I will assume at this surface, we have location number 1. So P1 divide gamma plus Z1 plus V1 square divide 2G at section number 1 or at location number 1 equal, I'm going to assume at this output or this outflow, I'm going to assume it's location number 2. So P2 divide gamma plus Z2 plus V2 square divide 2G. Does that make sense? That makes sense? So guys, if you are looking to this point, what is the pressure? Above this point, do you have pressure? Do you have pressure gamma H? No. This term will be 0. What is the elevation of this surface of water? It's given 550. What is the velocity? Do you think the water at this surface is moving? Probably yes, but it's very, very, very slow. We don't have velocity. So V1 squared divide 2G equals 0. Equal. What is the pressure above this point? Do you have gamma H? No, we don't have. 0. What is the elevation of this outflow? It's given 525. We have velocity, yes. We have this flow at the output or at the outflow. We expect velocity. V square 2, V2 square divide 2G. The only unknown in this equation is V2. So 550 equal 525 plus V2 square at the outflow divide 2G. G will be 32.2. Guys, just to remind you, we have a term called G, which called acceleration of gravity. I'm still reminding you. Acceleration of gravity equal 9.81 meter per second square or 32.2 feet per second square. If you are talking about US unit, so G will be 32.2. This is the reason why I put G 32.2. The only unknown in this equation is V2. I can figure it out. This velocity will be 40.12 feet per second. Any question? Do you have any question so far? It's very easy. Just keep in your mind, we have a tank. This tank is connected by a pipe. So I feel like this water will flow through this pipe. So we have outflow. This outflow has a velocity. How much? I don't know. So I selected this location as section number 1 and this location at section number 2. And I said P1 divide gamma plus Z1 plus V1 square divide 2G equal P2 divide gamma plus Z2 plus V2 square divide 2G at section number 1 and section number 2. Just for your information, if you are talking about a point under the effect of air, we don't have pressure. This point also under the effect of air, we don't have pressure. This water surface in the tank will not flow with a high velocity. It's a very, very, very slow movement. So we will assume velocity at location number 1 is 0. What is the elevation here is Z1. What is the elevation here is Z2. Then I can apply the rest of the equation to figure out the velocity at the outflow. This is what I did in this example. One more time, do you have any question? If you have any question, let me know. Okay. But I would like to be honest with you. Do you think if we have a pipe from two cities, between two cities, like Commerce and Dallas or Greenville and Dallas, do you think the energy at this location will be the same like energy at this location? I don't think so, because we have friction. That makes sense? Between the flowing water and the surface, the inner surface of the pipe, we have friction. Friction means losses. Losses means the energy will be lost. Not all of the energy, but a little bit between this section and this section. So what I covered just a minute, I'm assuming neglecting any type of losses, but this is ideal case. But in the real life, this equation must be written like this. P1 divide gamma plus Z1 plus V1 square at section number 1 equal the energy at section number 2. P2 divide gamma plus Z2 plus V2 square divide 2G. We need to add a term here, plus HL, which called head or total head loss. HL, total head loss. That makes sense. During the flow in any system in this world, we can expect losses for many reasons. But the main reason for friction, because we have two material, water and another material for the pipe, probably steel, probably concrete, probably plastic. Okay, we have two different material. So we have water and another material. One of them is moving, the water is moving. So we have friction in between. This friction will decrease, will try to decrease the energy, probably decreasing the pressure, probably decreasing the velocity. Both of them, I'm not sure, but we can expect losses. So I added another term to the equation. So this one is the actual energy equation. This one must be used. Okay, this is the real life situation. Just for your information, HL called total head losses. This total head losses can be divided to two type of losses. One called HF, which is friction losses. Most of the head loss coming from friction losses. So this part is large. And HM, which called minor losses, this part is very small, can be neglected. But if you would like to consider it, that will be great. So guys, the total head losses can be friction losses or can be minor losses. Any question so far? Just to give you a good hint. If you are considering losses, okay, the energy at section number 1 is P1 divide gamma Z1 plus V1 square divide 2G. The energy at section number 2, P2 divide gamma plus Z2 plus V2 square divide 2G. Because we have losses between section number 1 and section number 2 coming from the friction, we need to add here H losses. That means the two terms or the two sides will be equal. This is the ideal, this is the actual situation. If you consider losses, this losses, H losses, can be HF friction losses or HM minor losses. For example, of the friction, we understand this pipe is made from concrete, for example, or made from steel, and you have flow. So we have friction between the two surfaces, the surface of the liquid and the surface of the pipe. This is friction losses. We understand this. What is the meaning of minor losses? It's very easy. If you have a pipe and this pipe is changed in the size, so entering from this smaller diameter to this larger diameter, we have losses at this entrance. Or vice versa, if you have larger diameter and the smaller diameter, so this flow to enter this smaller one, we can expect here losses. All of these type of losses can be considered as minor losses. It's very, very small, very small. If you consider it, you will find it's very small. The most critical losses, which is the friction losses. Okay, let's figure out the first type of losses, which is called friction losses. Friction losses is the disruption of the flow caused by contact with the inside surface of the pipe. That makes sense. The amount of friction loss depends on the velocity. If you have faster flow, we can expect more losses, I believe. Length of the pipe, that makes sense. And the roughness of the pipe, the material of the pipe. I believe the most smooth surface is the plastic. We have three different types, I believe, of pipes. This pipe can be made from steel, can be made from concrete, can be made from PVC or plastic. Each material has different roughness. So the amount of friction losses depends on three parameters. What is the velocity of flow? What is the length of the pipe? And what is the roughness of the pipe? Roughness of the pipe depends on the material of the pipe. Does that make sense? So probably during the exam, I will ask you guys, what are the parameters affected or affect on the amount of friction loss? Did you get my question? Probably during the exam, By the way, this exam is open book, open note. I will ask you a question saying, hey, what are the factors affecting the amount of friction losses? We have three factors. Number one, the velocity of flow, the length of pipe, and the roughness of pipe, which depend on the material of the pipe. That makes sense? Any question? If you would like to calculate the amount of friction losses, we need to use Darcy equation. This equation, HF, which is friction losses, equal F times L divide D times V square divide 2G. D is the diameter of the pipe. L is the length of the pipe. V is the velocity of the pipe, of the flow. G is the acceleration of gravity. Then we still have one parameter, which is F. F is called the Modi-Darcy friction factor based on the material used for the pipe. And this factor can be found from this chart. Based on this value, divide D, where epsilon is the roughness of the pipe. How can I figure out the value of this roughness? Okay, from this table. If the material used for the pipe is concrete with finished surface, the value of epsilon equal 0.001. So epsilon equal 0.001. That makes sense? That makes sense? Then you need to divide this epsilon or this roughness by diameter of the pipe. So D is the diameter. You will get a value. For example, your value equal 0.004. So I'm gonna put here the value 0.004, which is this one. Then you can go to the other side and figure out the value of F. So we have here 0.02, we have here 0.03. I believe this one will be 0.028. That makes sense? So the value of F can be found from this chart using the perimeter or the term roughness divide diameter. Roughness from this table based on the material. So probably in the problem, I will give you the material used for the pipe. From this table, you can figure out the roughness. Then divide this roughness by diameter to get a value. Put this value here, go to the other side. You can figure out the value of F, which is the friction factor used in this equation. That makes sense? That makes sense? Let's do this example. Let's do this example. We have a water is flowing in 36-inch concrete pipe finished surface. Hey, wait. this pipe with a diameter equal 36 inch. This pipe made from concrete with finished surface with a velocity, so the velocity in this pipe equal 12.5 feet per second. What is the friction head loss over the length of the pipe length equal 225 feet? What is the head loss? What is the friction head loss? What is the HF? Okay, HF based on Darcy equation equal F L divide D V square divide 2G. I believe everything is known except F. Okay, what is the type of material? Concrete with finished surface. So what is the roughness? Go back to this table. Concrete with finished surface, the value of roughness 0.001. What is the roughness divide diameter? 0.001 divide diameter 36. Be careful, be careful, be careful. This roughness value in feet. So 0.001 is feet. And right now you are dividing feet by inch. Doesn't make sense. You need to convert one to the other one. So this one will be 0.0003. I converted 0.01 the same. I converted 36 inch equal 3 feet. This value will be 0.0003. That makes sense? So I will go back to this chart for a value 0.0003. I believe we will be here. That makes sense? Please go to the other side. Horizontally, exactly. Probably we are here. What is the value? This value is 0.01. This value is 0.02. So I believe 0.012, 14, 16, 18, 20. So this 1.012, 14. I think this value will be 0.015. Something like this. So the value of F equal 0.015. Does that make sense? 0.015, yes. So finally, the friction head losses equal 0.015 F, the length of the pipe 225, the diameter of the pipe is 3. Guys, make sure you are working using the same unit. This length in feet, this diameter must be in feet. Time V square, which is given 12.5 square, divide 2G 2 times 32.2. I can get the final answer. .7 feet. So the total, the friction head loss, which is called HF, will be 2.7 feet losses. It's very easy, very simple. You need to read your problem carefully. We are looking for the friction head loss equal F times L divide D V square divide 2G. Any question? If you have any question, let me know. Okay. The second example will be the last one for today. We can expect one like this in the coming exam. We have two tanks, tank number 1 and the tank number 2. And we have a pipe with diameter 8 inch connecting between the two pipes. The two tanks. Okay. And we are looking to determine the quantity of flow in the pipe. In this pipe, what is the value of Q? I understand that we learned from last week discharge in any pipe equal area times V. The area of this pipe, I can figure it out using this diameter. But what is the velocity of flow in this pipe is still unknown. From today, we understand that if you decide this surface, location number 1, and this surface of this tank, location number 2, I can say P1 divide gamma plus Z1 plus V1 squared divide 2G equal P2 divide gamma plus Z2 plus V2 squared divide 2G, but we are talking about real problem. We need to consider losses. So we need to add here HL. Does that make sense? I believe surface number 1, under the effect of air, we don't have pressure. I believe surface number 1 is the surface of a tank, which is very, very, very slow. We don't have velocity. The elevation of surface number 1, 275 is given. This value. So this term is 0, this term is 0. The other side, you are lucky, because this side also at surface number 2 is a surface of a tank. We have air pressure, so this pressure is 0. What is the elevation here? 255. What is the velocity here? Will be 0, because it's a surface of a tank. Guys, we have a big difference between this example and the current example. This one, we have here a very large velocity. But this example, this pipe is connecting between two tanks. So the water surface here has 0 velocity. Plus H loss. Anybody can tell me what is the value of H loss? I think H losses will be 275 minus 255. It will be 20 feet. That makes sense? That makes sense? Okay. This H losses based on this one equal H minor plus H friction. Because the problem said this, please consider friction losses only. So I will neglect this term. So the final conclusion will say H friction equal 20 feet. So the friction in this pipe due to friction equal 20 feet. Okay, this 20 feet equal F L divide D V square divide 2G. That makes sense? The length of this pipe approximately 500. The diameter of this pipe 8 inch. So 8 divide 12 to be in feet. G 32.2. What is the value of friction? Okay, this pipe made from smooth concrete pipe. Smooth concrete pipe. So the roughness will be 0.001. Diameter in feet, 0.67 feet. So epsilon divide D will be 0.0015. So I will enter this curve for a value 0.0015. I believe we will be here. 0.0015. If you go to the other side, the value of F will be here 0.0125. I think 0.0125. So F will be 0.0125. The only unknown in this equation is velocity. I can figure it out. 0.0125 times 500 divide 0.67 divide 2 times square root. This velocity will be 11.7 feet per second. Once you get the velocity, put the value of the velocity here, and you already know the area, multiply area by V, you can get the discharge. Your discharge will be 4.14 cubic feet per second. So guys, to repeat this example one more time. It's very important. We have a tank here, and we have another tank here. I connected between the two tanks by a pipe. What makes sense for me, the flow will coming from the upper tank to the lower tank. Can you tell me what is the discharge in this pipe? The discharge equal area, the cross-section area of this pipe, time V, the velocity. How can I calculate the velocity? Okay, I will assume this surface is surface number 1, and this surface is surface number 2. I will apply first the energy equation between the two surfaces, the two locations. So P1 divide gamma plus Z1 plus V1 squared divide 2G equal P2 divide gamma plus Z2 plus V2 squared divide 2G plus H losses. This is the actual situation. Because we don't have any water above this point, we have air only, this pressure equals 0. Because it's a surface of a tank, we don't have velocity. The same situation at the second location. So we have Z1 equals Z2 plus H losses. The elevation of this surface is given. The elevation of this surface is given, which are Z1 and Z2. So I can figure out the value of H losses equal 20 feet. That makes sense? H losses equal H minor plus H friction. We have two terms. But the problem, if you read it carefully, said, please consider friction losses only. So I will neglect this term. So the final conclusion, H friction equal 20 feet. Okay, we understand that H friction equal F L divide D V square divide 2G. I can figure out the value of F, length, diameter, G. The only unknown in this equation is the velocity of flow. This velocity of flow is the velocity of flow inside this pipe. Once you get this velocity, okay, I can get the velocity right now. I know what is the area of this pipe. If you multiply the two terms, I can figure out the discharge. What do you think? Any question? This example is very important. This example is very important. This example is very important. Do you have any question? If you have any question, let me know. This example will be done in 3 steps. The first step, apply energy equation to figure out the total losses. This total losses will be the same value like friction losses. Second step, you need to apply Darcy equation. Friction losses equal FL divide dV squared divide 2G. From this equation, I can figure out the velocity of flow in the pipe. The third step, the discharge in this pipe equal area times V, the velocity that you calculated. Area, the area, and make sure everything is consistent in units. So this area will be pi divide 4 times diameter square. And here is the V. This one must be in feet square, this one in feet per second. So the final answer will be cubic feet per second. My number was 4.14 cubic feet per second.